While having important role in their biological activities, the group 2 elements of alkaline earth metals have some useful applications, like beryllium is used mostly for military applications, but there are some other uses as well. In electronics, beryllium is used as a p-type dopant in some semiconductors, and beryllium oxide is used as a high-strength electrical insulator and heat conductor. Due to its lightweight and other properties, beryllium is also used in mechanics when stiffness, lightweight, and dimensional stability are required at wide temperature ranges. Magnesium has many uses. It offers advantages over other materials such as aluminium, although this usage has fallen out of favor due to the magnesium's flammability. Magnesium is also often alloyed with aluminium or zinc to form materials with more desirable properties than any other pure metal. Magnesium has many other uses in industrial applications, such as having a role in the production of iron and steel and the production of titanium. Now, some of the other useful applications of these alkaline earth metals are these magnesium sulfates have many uses in the petroleum industries as well as in other industries. Then calcium has many uses like reducing agent in the separation of other metals from ore, such as uranium. It is also used in the production of alloys of many metals, such as aluminium and copper alloys, and is also used to deoxidize alloys as well. Then calcium also has a role in the making of cheese, mortars, and cement. Now we see the uses of strontium and barium. They do not have as many applications as the lighter alkaline earth metals, but still have some uses. Like strontium carbonate is often used in the manufacturing of red fireworks, and pure strontium is used in the study of neurotransmitter release in the neurons. Now, the radioactive isotope of strontium, that is strontium 90, it finds some uses in RTGs, which utilizes its decay heat. Now we see this barium has some use in vacuum tubes to remove gases and barium. Now, due to its reactivity, radium has no longer many applications, but it used to have many of them. Radium used to be used often in the luminous paints, although this use was stopped after workers got sick, as people used to think that radioactive was a good thing, and radium used to be added to drinking water, toothpaste, and many other products, although they are also not used anymore due to their health effects. Radium is no longer even used for its radioactive properties, as there are more powerful and safer emitters than radium. Now, how these elements in the form of ions in solution can be identified with the help of their specific selective chemical reagents, like magnesium ions. Disodium phosphate is a very selective reagent for magnesium ions, and in the presence of ammonium salts and ammonia, it forms a white precipitate, that is ammonium magnesium phosphate. Here we see the chemical reaction which takes place. Then calcium ions forms a white precipitate with ammonium oxalate. This white precipitate is calcium oxalate, and it is insoluble in water, but is soluble in mineral acids. Now, strontium ion can be identified by its chemical reaction with the reagent sodium sulfate. Strontium ions precipitate with the soluble sulfate salts, that is strontium sulfate. All ions of alkaline earth metals form white precipitate with ammonium carbonate in the presence of ammonium chloride and ammonia. This is thus they can be identified. Now, to follow the chemical properties and their trends of the various elements of group 2, that is alkaline earth metals, in the chemical behavior, we have to go through the electronic configurations. So first we see the beryllium with atomic number 4 has electronic configuration of 2 2 and innermost completely filled inert gas configuration of helium gas, outermost is 2s2. We'll see the common trend of outermost s orbital occupied by 2 electrons. Then magnesium with atomic number 12 has configuration of 282 with the neon inner shell configuration and outer shell is 3s2. Then calcium with atomic number 20 configuration 2882 and inner shell inert gas configuration, that is organ, and outermost is 4s2, that is again the 2 electrons that occupy outermost s orbital. 38 atomic number of strontium has configuration of 281882 with the inner configuration of inert gas krypton and outermost completely filled s orbital with the 2 electrons, that gives 5s2. Then barium 56 atomic number configuration 28181882 inert gas configuration, that is from xenon, and 6s2 is the outermost completely filled s orbital. Then 88 atomic number of radium has configuration 2 8 18 32 18 82 with the radon inert gas configuration of the inner shell, while the outermost shell configuration comprises of 2 electrons in the 7s orbital, that is completely filled, and that is the common trend followed by the 2 group electrons of this s block elements. Now we see the trend in the general physical and chemical properties, that is based on these electronic configurations. The alkaline earth metals are all silver colored and soft and have relatively low densities, melting points and boiling points. In chemical terms, all of the alkaline earth metals react with the halogens to form the alkaline earth metal halides, all of which are ionic crystalline compounds. Again, we see the exceptional behavior of beryllium in the form of its halides, that is, beryllium chloride forms a covalent compound. All the alkaline earth metals except beryllium also react with water to form strongly alkaline hydroxides and thus should be handled with great care. The heavier alkaline earth metals react more vigorously than the lighter ones. The alkaline earth metals have the second lowest first ionization energies in the respective periods of the periodic table because of their somewhat very low effective nuclear charges and the ability to attain a full outer shell configuration by losing just 2 electrons. And that is why the second ionization energy of all the alkaline metals is also somewhat low. So then we will follow the chemical properties on this basis of their ionization behavior, ionization properties, and their other electron affinity properties of the two group elements.